Greetings everybody. Let's talk a little bit about general reflections now. Let's suppose that we want to reflect across an arbitrary line, and let's say it's y is equal to mx. So the idea is that we've got this line and we want to send the point P on one side to the point Q on the other side and vice versa. So how can we go about doing this? Well, the idea is that we can use the compositions of work that we've already done, our rotations and our reflections about the x and the y axis. So let's see exactly how that's going to work. So we can begin by rotating our line y is equal to mx to the x-axis. So if the angle there from the x-axis up to the line is going to be theta, remember that that is really just that our slope m is just the tangent of theta. And so let's take the case that if m is going to be positive, then we've got the right triangle, and so the tangent of theta being m over 1 leads us to the sine of theta being m over the square root of 1 plus m squared, and the cosine of theta being 1 over the square root of 1 plus m squared. And so what we can do then is a rotation clockwise. So we can do a rotation clockwise by an angle theta that will take our line y is equal to mx down to the x-axis. And so from the previous video, we know that that's going to look like r sub theta being cosine of theta, sine of theta, minus sine of theta, cosine of theta. Well, once we do the reflection across, once we do the rotation so that our line goes down to the x-axis, now we can do a reflection across the x-axis. And remember that that looked like just the matrix 1, 0, 0, negative 1. And then once we do a reflection, now the idea is to rotate backwards back. So we're going to rotate counterclockwise now by that same angle theta. And so that's going to be our matrix cosine of theta minus sine of theta, sine of theta, cosine of theta. So if we want to do a reflection across the line y is equal to mx, then it's just the composition of those three transformations. We've got r sub theta, t being our reflection across the x-axis, and then our rotation back, r sub minus theta. So if we look at those three matrices, then we just multiply those together and we end up with an expression that looks like cosine squared minus sine squared, 2 sine theta cosine theta, 2 sine theta cosine theta, and sine squared minus cosine squared. So if we kind of go back to our trig identities for those, then this just really gives us cosine of 2 theta, sine of 2 theta, sine of 2 theta, and minus the cosine of 2 theta. So if we take the special case where we've got y is equal to 2x, then that leads us to the cosine of theta being 1 over the square root of 1 plus 2 squared, so it's 1 over root 5. Sine of theta is then 2 over root 5, and so our linear transformation L that does this reflection is just negative 3/5, 4/5, 4/5, and 3/5. So now what we can do is take the point 1, 5, and so we'll just take that arbitrary point 1, 5, and what if we do the reflection about the line y is equal to 2x, what point do we end up with? Well, if we go negative 3/5, 4/5, 4/5, 3/5 times our vector 1, 5, that gives us the vector 17/5, 19/5, which is really just 3.4 and 3.8. So now let's get an idea and see if this actually does check out. Let's try doing this in Geogebra and see what happens. Alright, so here we are over in Geogebra. So now let's get that graph going. So we said in our example we were using the line y is equal to 2x. So y is equal to 2x. We'll get that one going. So there's our line. And then we said if we picked the point 1, 5, so let's say we've got our point 1, 5 there. Now the nice part about Geogebra is that we can just tell it to do that reflection. Let's reflect about that line. So here's the reflection about the line. We want to reflect that point around our line y is equal to 2x, and sure enough, what value do we end up with? We end up with a value of 3.4 and 3.8 for the coordinates, exactly as we thought we should have. And so if we've got just kind of a general reflection around any line, then what that gives us is we can view that as a composition of rotations, reflections, and then rotations back to give us the linear transformation that we want. So I hope that this has been kind of informative for you. I hope you've enjoyed it, and I will see you guys next time.